Limit is y goes to 2 of the square root of y squared plus 5 minus the square root of 3y squared minus y minus 1 divided by 2 minus y. First thing we're going to do is try plugging a 2 in for each of the y's. So we will have the square root of 2 squared plus 5 minus the square root of 3 times 2 squared minus 2 minus 1 divided by 2 minus 2. We'll have the square root of 2 squared, which is 4, plus 5, minus the square root of 2 squared is 4 times 3 is 12, minus 2 minus 1 is minus 3, all over 2 minus 2. So we have the square root of 4 plus 5, which is 9, minus the square root of 12 minus 3, which is 9, divided by 2 minus 2. The square root of 9 is a 3, minus the square root of 9, another 3. 3 minus 3, which is 0, over 2 minus 2, which is also 0. We have the 0 over 0 indeterminate form. We will need to rework this. Since we have a root combination, a root involving the variable y in some way, added or subtracted together with at least one other term, that's happening in the numerator, we can try the root conjugate method. So I'm going to rewrite this limit exactly as we see it, square root of y squared plus 5 minus the square root of 3y squared minus y minus 1 divided by 2 minus y. And we're going to multiply this by the root conjugate of the root combination, which is the same terms in the root combination but opposite sign between them. So I will want a plus here. Other than that, everything's identical. And then we're going to put this over itself so that we have a form of 1, so that when we multiply it, it will not change the value. It will just change the look. In the numerator, we have conjugate pairs, so we're going to FOIL that out first. Root y squared plus 5 times root y squared plus 5 will be a y squared plus 5. Outside, positive root y squared plus 5 times positive root 3y squared minus y minus 1 will become a positive root of y squared plus 5 times 3y squared minus y minus 1. Inside, negative root 3y squared minus y minus 1 times positive root y squared plus 5 will be a negative root of 3y squared minus y minus 1 times y squared plus 5. And then the last will be a negative root of 3y squared minus y minus 1 times a positive root of 3y squared minus y minus 1, which will be negative due to one of them being negative. And then the quantity of 3y squared minus y minus 1. That entire thing will be divided by the denominator, which is not root conjugates, and therefore we will not FOIL it out. They are multiplying each other. So we're going to write them multiplying each other, but not actually FOIL them. In the numerator, in the root conjugates, the outside and inside terms are equal value, opposite sign always, and they cancel each other out. And then the other thing is that negative sign we need to distribute into this expression. That's going to be our next step. So that'll give us limit as y goes to 2 of y squared plus 5 minus 3y squared plus y plus 1. Notice they are all becoming opposite signs of what they used to be, divided by 2 minus y, square root of y squared plus 5 plus square root of 3y squared minus y minus 1. So now what we're going to do is combine together like terms in the numerator. We have two y squared terms. We have one here and we have one here. We'll combine those. And we have two constants. We have one here and we have one here. We'll combine those. So that's going to give us a negative 2y squared plus y, and then plus 6. And then divided by the denominator, which I'm not doing anything with just yet. So we've finished the root conjugate multiplication and simplification. Okay, we'll not ever eliminate the 0 over 0. We still have it, but we've turned into power functions here, so we can try the power function method of factor cancel. We're getting a 0 in the denominator because of that, and in the numerator because of that entire expression. So we will need a factor before we can cancel out. So that's going to be our next step. It looks like we're going to start by maybe factoring out a negative 1 from the numerator so that we can have a positive 2y squared. It'll just make the factoring a little easier to deal with. Make sure you change the signs on all of those so it'll be a negative y and a negative 6. Divided by the same denominator. We haven't done anything with that just yet. So this will be y squared plus 5 plus the square root of 3y squared minus y minus 1. Okay, now we can try our trinomial factoring in the numerator. Since it's a 2y squared, it's going to require a 2y and a y. And we need two numbers that multiply to be a negative 6, so they're going to be opposite signs of each other. We can try 6 and 1. If we put a 6 here and a 1 here, that'll give us a 12 and a 1. That's not going to combine to give us the negative 1. Okay, so we can try maybe the 6 here and the 1 here. That'll give us a 6 and a 2. Those can't combine to give us a negative 1. Okay, so not that either. So it must be the 2 and the 3. We can put a 2 here and a 3 here. That gives us a 4 and a 3, and that will work out to give us a negative 1, granted that the 4 is a negative 4, so we'll want that to be minus and that to be plus, and that should take care of it for us. Now in the denominator, I have a 2 minus y, which is making a 0, but it's not going to match the factor in the numerator right now. It's opposite sign. So let's go ahead and factor in negative out of that denominator so that it also becomes a positive y and a negative 2. And at that point, we should be able to cancel those out, and that will remove our 0 over 0 indeterminate form. So let's go ahead and cancel those. And we can also cancel the negative since we have 1 in the numerator and 1 in the denominator as well. So that gives us now, limit as y goes to 2 of 2y plus 3 divided by the square root of y squared plus 5 plus the square root of 3y squared minus y minus 1. We should no longer have 0 over 0. We canceled the factors out that were making 0 over 0, so we can now plug a 2 in for each of the remaining y's. In the numerator, 2 times 2 plus 3 divided by, in the denominator, 2 squared plus 5 plus the square root of 3 times 2 squared minus 2 minus 1. So that will give us in the numerator, 2 times 2 is a 4 plus a 3. In the denominator, 2 squared is a 4 plus a 5. And then plus the square root of 2 squared is 4 times a 3 is a 12. And then minus 2 and minus 1. In the numerator, 4 plus 3 is a 7. In the denominator, the square root of 4 plus 5 becomes the square root of 9. And then the square root of 12 minus 2 minus 1 is also the square root of 9. So we end up with a 7 divided by a 3 plus a 3, or 7 over 6.